Okay, so I wanted to re-record this lesson since there were a lot of technical difficulties last time, but today we're going to talk about partial fractions and long division. So sometimes you might have an integral like this one, which I should have a dx at the end of, but I have 1 over x squared minus 4. Now, we don't actually have a way to calculate that at this current point in time. So what we can use is what's called the Heaviside method. Well, to do the Heaviside method, you're going to break this up by factoring into 1 over x squared plus 2, 1 over x squared minus, or x minus 2. And then we're going to use the Heaviside method by covering up one variable. So what would make this plus 2 equal to 0? Well, I know it's going to be negative 2. So if I have negative 2 equal to 0, and if I substitute in negative 2 for x, I'm going to have 1 over negative 2 minus 2, which equals negative 1/4. Now I'm going to take that negative 1/4 and put it over that original factor that I created. So I'm going to put it over x plus 2. Now, what plus negative 2 would equal 0? Well, I know that's going to be 2. So if I cover this up and I substitute in 2 for x, I'm going to have 1 over 2 plus 2 is 4, so that of course just equals 1/4. Now I'm going to put 1/4 over x minus 2. So then I can actually just integrate. I could factor out like this 1/4, this negative 1/4 and 1/4, but you can see here we're just going to have 1 over x plus 2, 1 over x minus 2. That's just the natural log. So this becomes negative 1/4 natural log of x plus 2 plus 1/4 natural log of x minus 2. And don't forget, you have to have plus c at the end. All right, let's try another one. Here we have x minus 11 over x squared minus 7x plus 10. Well, if I factor this, I'm going to get x minus 11 over x minus 5 times x minus 2. Nothing's going to cancel out, and this is still too complicated to be able to factor. So I need to figure out what plus negative 5 will equal 0. Well, I know that's going to be 5. So I cover this up, and I'm going to substitute. I'm going to have 5 minus 11 over 5 minus 2, right? So that's going to be negative 6 over 3, which is negative 2. So I'm going to put that negative 2 over x minus 5. Likewise, what plus negative 2 is equal to 0? Well, it's going to be 2. So I can cover this up. I have 2 minus 11 over 2 minus 5. So I get negative 9 over negative 3, which just equals a positive 3. So I put that over x minus 2. I then integrate, and I get negative 2 ln of x minus 5 plus 3 ln of x minus 2 plus c. Let's do a little bit here. Here I have 3x plus 6 over x squared plus 3x dx. Well, I can factor this to just be 3x plus 6 over x times x plus 3. I still have nothing that cancels out, because if I factored out the 3 here, I'd have x plus 2. So what plus x would equal 0? Well, it's just going to be 0. So if I cross that out, I'm going to end up having 3 times 0 plus 6 over 0 plus 3, which of course just equals 6 over 3, which equals 2. So I put 2 over x. Now what plus 3 would equal 0? It's going to be negative 3. I cover that. So I'm going to have 3 times negative 3 is a negative 9 plus 6 over a negative 3. So that's negative 3 over negative 3, which just equals 1. So I put 1 over x plus 3. Then integrate, so I get 2 natural log of x plus natural log of x plus 3 plus c. Okay. Here we've got one that's even longer. We've got x squared plus 12x plus 12 over x cubed minus 4x dx. Well, if I factor my denominator, I'm going to get x times, like this would be x times x squared minus 4, which becomes x times x plus 2 times x minus 2. So I can't factor my numerator, but I can separate this out. So what times x would be 0 is just going to be 0. So if I cover that up, I'm going to get 0 plus 12 over 2 times negative 2, which equals 12 over negative 4, which equals negative 3. So I put negative 3 over x. What plus 2 is 0? It's negative 2. So I cover that. I'm going to get 4 minus 24 plus 12 over negative 2 times negative 4, which looks like I did over here. That would be This would be negative 12. 4 minus 12 is negative 8 over negative 8, which just equals 1. Oh, wait. 4 minus, is that negative 1? It should be a negative 1. Oh, yeah, because this is positive. There we go. So I put negative 1 over x plus 2. And then finally, 2 is going to be my last variable, or last number to test. So I'm going to have 4 plus 48 plus 12 over 4. Oops, why am I saying 4? Oh, okay, sorry. 4 plus 24 plus 12, right? Because this is 2 that I'm using here, over 2 times 4. So that's going to be 3640 over 8, which is equal to 5. And I put 5 over here. And then I can integrate 3 ln of x minus ln of x plus 2 plus 5 ln of x minus 2 plus c. That's a c right there. Okay, so now that we've kind of mastered how to do that, separation of, what am I calling this? Partial fractions, that's what I want to call it. Now let's do long division. So you can do long division this way by writing out 3, 8, negative 10, 15, and then dividing by negative 4. But to be honest with you, I actually like doing it another way. So I prefer, this is the synthetic division way. So if you do this, you're going to bring down 3. 3 times negative 4 is negative 12. 8 plus negative 12 is negative 4. Negative 4 times negative 4 is 16. Negative 10 plus 16 is 6. 6 times negative 4 is negative 24. 15 plus negative 24 is negative 9. So then this is my remainder. So I'm going to rewrite this as 3, and like these terms all line up. So it's going to be 3x squared minus 4x plus 6 minus 9 over our divisor x plus 4. Then I integrate, I get x cubed minus 2x squared plus 6x minus 9 natural log of x plus 4 plus c. Now that's one way to do this, but I actually prefer this way. Here I've got x minus 5 over 2x minus 2. I prefer to write x minus 5 and divide by 2x minus 2. Well, how many times does 2x go into x? It goes in 1/2 times, right? So 1/2 times 2x is equal to x. So I'm going to have x, and then 1/2 times negative 2 is a negative 1 actually. Then I subtract, that's how this became positive, and I get a negative 4. So I now have integral of 1/2 plus negative 4 over my divisor, 2x minus 2. I can integrate, so I'll get 1/2 x, yep, minus, and minus 4, why did I write that? Minus 4 over 2, oh, negative 4 over 2, that just simplifies to negative 2, that's why. 2 ln of x minus 1 plus c. Okay. 2 more examples for you, 4 more examples. Here we've got x cubed plus x divided by x minus 1. X minus 1 goes into x cubed, x squared times. X squared times x is x cubed. You can kind of see all of this here. We get down, our remainder is 2. So I rewrite this as x squared plus 2 over x minus 1 dx. I integrate, and this is what I get. Okay, x cubed over 3 plus x squared over 2 plus 2x plus 2 ln of x minus 1 plus c. For number 8, another long one, we have 2x cubed plus x squared minus 11x plus 20. We divide by x squared plus 2x minus 3. We get 2x minus 3 with a remainder of x plus 11. Now that's okay. So we're going to have 2x minus 3 plus x plus 11 over x squared plus 2x minus 3. Now this part actually needs to be done using partial fractions. So I can integrate this as normal, which I've done, but then I need to use partial fractions here. So I end up getting, using my Heaviside function, 2 over x plus 3 over x minus 1. And I write this out, x squared minus 3x plus 2 ln of x plus 3 ln of x minus 1 plus c. So you can see how these can be embedded in one another, these types of techniques. All right, 2 more examples. The sine of x over cosine of x times cosine of x plus 1. Well, if I set u equal to the cosine of x, then du is going to be equal to the negative sine of x. So I would end up having negative du over u times u plus 1. Once I have that, I can use partial fractions. So I break this up, and I'm going to end up having a negative 1 over u plus 1 over u plus 1. Then I integrate, I get negative ln of u plus ln of u plus 1 plus c, and I can substitute back in, so I finally get negative natural log of cosine of x plus natural log of cosine of x plus 1 plus c. Number 10, we're going to set u equal e to the x and du equal e to the x dx. Now, how is that going to work? Well, I can rewrite this. If I divide here, I'll cancel out that numerator. I'll have 1 over u squared minus 1. Right? Now I can factor that as u squared minus 1 times u, or u minus 1 times u plus 1. I'm going to use my Heaviside function, and I'll get positive 1/2 and negative 1/2 here. I then integrate, so I get 1/2 natural log of u minus 1 minus 1/2 natural log of u plus 1 plus c. And then I just substitute back in that e to the x. So my final answer is 1/2 natural log of e to the x minus 1 minus 1/2 natural log of e to the x plus 1 plus c. Hopefully that explanation cleared some things up for you a little bit. I know it wasn't a lot of me calculating because it's already been done, but I look forward to seeing you in class. Bye!